All right, so we're going to be talking about polarity today, but it's important to talk about electronegativity because when you define polarity, you define it by the change in electronegativity. So if we don't know what electronegativity is, we don't know what's up, okay? So electronegativity, just for you, is the ability to attract electrons, okay? So it increases as you go to the right, and it decreases going down. So it increases going up like this, and then it increases going this way to the right, okay? That's our trend for electronegativity. Okay, and that's because a large atom is going to have a very strong, very small ability to attract electrons from another atom. A small atom, okay, its nucleus is closer to the outside shell, is going to be able to attract other electrons more. All right, so that's a little bit of electronegativity review. So polarity. Polarity is talking about the unequal sharing of electrons. It's talking about the difference in electronegativity values. Okay, so it's the difference in electronegativities and how much the two atoms are sharing those electrons. Okay, where are the electrons more toward which atom? Okay, so electronegativity values, these are all on a electronegativity periodic table, and I'll give you a chart. Okay, and they're on a scale of 0.5 to 4. So fluorine is our most electronegative atom, and it's got a value of 4.0. Okay, so what we're going to be doing is we're going to use those electronegativity values, and we are going to be doing a little calculation for them. When we're talking about difference, okay, talking about change, all we're going to do is we're going to use this delta symbol, which is a triangle, and we're going to look at the change in electronegativity. When we're looking at change in math class, we subtract. Okay, so that's what we're going to do. If that change in electronegativity is less than 0.7, you've got a nonpolar covalent bond. Okay, so it's not polar. The electrons are being shared equally. Okay, so they're very similar electronegativities. If the electronegativities are a little bit different, and their difference is between 0.7 and 1.5, that's going to be a polar covalent bond. They're unequal sharing of electrons. They're unequal. Okay? If the electronegativities are so different that they're greater than 1.5, that's going to be an ionic bond. That means your electrons aren't even being shared unequally. They're not being shared at all. They're being transferred. So that's a transfer of electrons. All right, so here's what we're going to do. I have given you some electronegativity values right up at the top of the page, and we're going to do some practice problems with it. So I'm going to do the first three, and then I want you to try the next ones. So for this one, H and H. Okay, so your delta En equals H, 2.1, minus H. That'll be 0. So that means it's less than 0.7, and it's going to be a nonpolar covalent bond. All right, let's try OH. An OH bond, we've got delta En, and we've got H, which is 2.1, minus 3.5. Okay, all right, and that's going to be 1.4. So we're going to do the absolute value of this. So it would really be negative 1.4, but we're going to do 1.4 is the change, okay? So it doesn't matter if you write it this way or if you think about it as 3.5 minus 2.1, okay, is 1.4. Same way. So some people like to take the larger electronegativity value and write that first. So this would actually be a polar covalent bond. This would be polar because it's less than 1.5. All right, how about H and Cl? So I'm going to write the larger one first this time. So delta En equals 3.0, which I got straight from the Cl, minus 2.1, and I get 0.9. That is also going to be polar. All right, I would like you to try the next three in your notes. Make sure that they're in there. Example 1, 2, and 3. Okay. When we're labeling bonds, sometimes we don't need the values. We just need to compare them. So what I like to do whenever I'm talking about polarity is start with my electronegativity and just make a little chart up at the top, electronegativity, so I have a reminder. It goes up and to the right, okay? And what we're going to do is we're going to label each as a partial positive or a partial negative. These are called partial charges. When we're talking about the polarity of bonds, we're going to write partial charges, okay? P-A-R-T-I-A-L, partial charges, okay? And those are going to be with a sigma plus and a sigma minus. A sigma plus looks like a S that's connected, okay? Or like an 8 that's not connected. Sigma minus looks like that, okay? So those are going to be how you're going to label your partial charges. You're also going to draw a crossed arrow, which is called a dipole arrow. Okay, dipole arrow. And it's going to be drawn towards the more electronegative item with a cross at the end. That looks like a plus sign, so you can remember that, all right? So let's try an OH bond. So I'm going to draw my O and my H bonded together. Okay, O is 3.0, H is 2.1. So O is more electronegative, which we also know if we look at the periodic table. Okay, and so I'm going to write my sigma minus there. And my sigma plus is going to go on my less electronegative or more electropositive element, all right? And then I'm going to draw my dipole arrow heading towards my electronegative element with a little cross then at the end. You'll notice the sigma plus and the cross of the dipole arrow will be the same, okay? That'll be in the same spot, all right? So now that we know how to draw a dipole bond, that dipole arrow and those partial charges, we can do that for an entire molecule. So what you're going to start out is you're going to draw your structural formula. You're going to draw it in that shape. You have to draw the molecular shape. And then you're going to compare your electronegativities, draw your partial charges, draw your dipole charges, and draw your overall dipole for the whole molecule. Okay, so for example, CO2 is going to cancel out. So if you guys notice, you'll have my carbon, my oxygens, and you'll notice that carbon is to the left, so that's actually sigma plus. That's going to be more electropositive. My O is my more electronegative, so I'm going to put my sigma minuses there. When I draw my little dipole arrows, I'm going to draw one along each bond. So one towards this oxygen, and then a second one towards this oxygen. And then you'll notice that they're pulling in opposite directions. It's kind of like a tug of war. And the direction of those dipole arrows is going to balance out. If any of you guys have done vectors in math class, same thing. Those vectors are going to cancel out, which means this is overall going to be nonpolar. So overall nonpolar molecule. Okay, even though it's got some polar bonds. All right, so let's try one of these. PF3. So I'm going to start by drawing my phosphorus. Okay, and then I've got my structural formula. I know I've got 5 here plus 21 here, so I've got to have 26 electrons. Okay, so I plant them all around. I know I've got to have single bonds because phosphorus bonds 3 times, fluorine only bonds once. Okay, so this will be my diagram. You can see with my domain groups, I've got a phosphorus that's got a lone pair, and then I've got my 3 fluorines, and that's going to be a trig pyramidal shape. Okay, so when I draw these, I have to look and see between phosphorus and fluorine, which is more electronegative. Well, fluorine. Fluorine is the most electronegative. So that's where my sigma minuses are going to go. Sigma minus, sigma minus, sigma minus. Right on the phosphorus is going to be a sigma plus. So along each of these bonds, I'm going to draw a dipole arrow. It's going to be headed towards the more negative thing, which is going to be the fluorine. Towards the fluorine, towards the fluorine. Don't forget to cross the ends of each of them, okay? So overall, I've got my central phosphorus, my lone pair, and then 3 fluorines coming out of it. So we're actually going to have the electrons are going to shift down towards the fluorines. That's going to be where they're going to be most heavily populated. So overall, my overall arrow is going to be in a downwards direction. So that's going to be my overall dipole. Okay, so this is overall polar. All right, that says overall. Overall. All right? And that is my polarity.